So we reviewed graphing lines yesterday, and next time we meet in class we're going to get into graphing quadratics. Quadratics are those x squared, ax squared plus bx plus c equations. And so I just want to talk still a little bit more. I'm sticking with lines still because we're going to talk about things that are of interest. And yesterday when we were graphing lines, we looked for the slope and the y-intercept to help us graph the line. And today we're actually going to focus on both the x and the y-intercepts. The x-intercept is the point x comma 0 where the function crosses the x-axis, and the y-intercept, this is the x-intercept, and the y-intercept is the point, intercept, is the point 0 comma y, and that's where the graph crosses the y-axis, okay? And so the y-axis is what we're looking for when we do the y-intercept. Now notice, the x-intercept goes in the form x comma 0. That means this happens when y is 0. And the y-intercept is 0 comma y, which means that this happens when the x is 0. So when I solve these for my x-intercept, I'm going to try and keep my colors so we can see them. I'll do this one in this color. It's supposed to be purple. I don't know how you see it, but my x-intercept, I'm going to abbreviate as x-int, happens when y is 0, so I rewrite this as x minus 0 equals negative 4, because I'm replacing the y with 0, and so anything minus 0 is itself, so x is negative 4. That means the x-intercept is negative 4 comma 0. And that goes on the graph right on the x-axis at negative 4. Now for the y-intercept, that's when the x part of it is 0. So I go up here and I replace the x with 0. X minus y equals negative 4, or negative y equals negative 4. And when I have negative y equals negative 4, I can get rid of that by just taking the opposite of everything, or multiplying by negative 1, or dividing both sides by negative 1. That's one way that people look at it, but really I can just change the signs on both sides. And so that's the point 0 comma 4. And so on the y-axis, 0 comma 4 is another point. When I find both of those, what that allows me to do actually is to find 2 points that are going to connect to make my line. And so x-intercept, y-intercept are an easy way to graph lines if you can find those 2 points. And it works pretty slick a lot of the times. So again, if I'm doing my x-intercept means that I replace the y with 0, so this is 2x plus 5 times 0 equals negative 10. Well, that's 2x equals, I should say, plus 0 equals negative 10, because 5 times 0 is 0. So 2x equals negative 10. A lot of times I just jump right down to this spot. I just get rid of the y term. 2x equals negative 10. Divide by 2 on both sides. X is negative 5, that's the point negative 5, 0. So I go to negative 5, make my point on the x-axis. And I'm going to go through that same process with the y-intercept. Y-intercept. That's when the x is 0. So I take 2 times 0 plus 5y equals negative 10. Well, that's 0 plus 5y equals negative 10, or 5y equals negative 10. Divide by 5, and y is negative 2. So I put my point at negative 2, because that's the point 0 comma negative 2. And then I can take those points and I can connect to make my line. That was a pretty crummy line, but you get my gist. Okay, so again, that method works pretty slick. We do have a problem though with using the x and y intercepts to sketch a graph of a line, sometimes because there are going to be instances where I maybe come up with not, like these came out really nice numbers. Maybe I'm going to come up with something that's not nice. Or another instance that I'm going to have, you'll see in problem number 4, is when everything turns into 0. And you'll see the problem that that poses. But anyways, I'm going to start this the same way. My x-intercept is when I replace y with 0, so 2x plus 3 times 0 equals negative 9. So 2x plus 0 equals negative 9. 2x equals negative 9. This is what I was talking about. Divide by 2, divide by 2. X is negative 9 halves. So this is a point, negative 9 halves, comma 0. Well, what is that? Where is that? That's actually negative 4 and a half, and we can come up about this a couple different ways. I could plug it in my calculator, 9 fraction key 2, and hit equals. It'll put it in that form. Or how many times does 2 go into 9? It goes in 4 whole times, left with 1/2, an old fraction technique that you learned probably in grade school. So that's the point, negative 4 and a half. So what I have to do is kind of approximate where that is. So I'm sometimes going to get a value that's going to be not an exact looking value, and it might be difficult to graph. Halves aren't too bad, but sometimes when I get thirds or fourths or fifths, it's kind of hard to approximate where they are. But I can still get a graph of a line, so I'm going to still continue this and find my y-intercept by replacing x with 0. I always think of it as I'm getting rid of the x because all I care about is the y. That's what the y-intercept is all about. So 0 plus 3y equals negative 9. Divide by 3, the 0 is going to 0 out. Y is negative 3, so I'll plot that point as 0, negative 3. Again, plot that point as 0, negative 3. Put my point there. Like I said, even though this first intercept was a fraction, it still gave me 2 points, enough to create the line that I'm interested in. So our last one, problem number 4, I'm going to go through that same process again. X-intercept is when I replace y with 0 because all I care about is the x. So 4x minus 5 times 0 equals 0. So 4x minus 0 equals 0. 4x equals 0. I divide by 4, divide by 4. I know I'm kind of working through that pretty fast, but hopefully you get what I'm doing. We've solved several equations by now. I end up with the point 0, 0. So that's 0 on the x-axis. So I plot that point. Now I'm going to go through that process again with the y-intercept. And you'll see, hopefully, the problem that's going to arise. My y-intercept means I replace my x with 0. Minus 5y equals 0. So 0 minus 5y equals 0. All right, that is negative 5y equals 0. Divide by the negative 5. Y equals 0. I have the point 0, 0. And there's my issue. My x and my y-intercept are the same. And when my x and my y-intercept are the same, I only get 1 point. And I can't tell where the line is going. At this point, there's no indication to me. Is it a positive slope? Is it a negative slope? Is it flat? Is it steep? I don't know. I only have 1 point, and 1 point does not make a line. So this is an instance where the intercepts isn't the most helpful way to do it. And so maybe I'm going to have to go and use one of those techniques that we used before and find my slope. Remember, slope from standard form, this is ax plus by equals c, and slope is the opposite of a over b. So I'll do my slope as the opposite of 4 over negative 5, or 4/5. Well, how does that help me? Because once I find a point on my graph, I can take my slope and use my rise over run, up 4, right 5, and then I have another point to create my graph. So again, x-intercept, y-intercept, another way to graph a line, kind of nice way to do it. I know I showed a lot of work when I went through here, but there are shortcuts that you can take if you feel comfortable with it. It's just that sometimes it's going to be a little hairy when you get a fraction or if you get 0, 0. So your job tonight is not to actually graph the line on your form your Google Doc, you're just going to enter the slope and the the x-intercept and the y-intercept. When you enter them as your answer, just write them with x first, and you'll put whatever your answer is. Like, let's say I'm doing this one, I would do -9 divided by 2, 0 as my x-intercept, 1 space, just leave a space. You don't have to do an underscore, just a space, and then 0, -3, no spaces in your parentheses when you enter them. Come to class next time we meet with questions, and we'll talk again soon.